You ship a feature on Friday afternoon. It seems fine. But deep in your production logs, a critical bug is pulsing away, completely unnoticed, waiting to ambush your team on Monday morning. Instead of relying on luck or an exhausted on-call engineer, you can build a production error sweep loop. It's a scheduled AI agent that hunts down those silent errors every night. While your team sleeps, this workflow pulls your logs, traces bugs to their source, writes the code to fix them, opens a pull request, and leaves a clean summary in Slack. To build this, you need 4 things: a structured error logging system like Sentry or Datadog, a code repository with a scoped bot token, a Slack channel, and MindStudio to tie it all together. By delegating the initial triage and root cause analysis to a machine, you stop reacting to customer complaints and start controlling your software quality. Step 1 is data ingestion. Inside the MindStudio canvas, you'll set a scheduled trigger, usually around 11 p.m., to fetch your application logs from the last 24 hours. You don't want the AI reading every single log. You have to filter the API request to pull only unresolved logs marked with the severity level of error, skipping the warnings entirely. Next, apply an occurrence threshold. Single errors are anomalies, so only fetch errors occurring at least 5 times. Cap this pull at exactly 50 errors per run to prevent overloads. Finally, cluster the remaining errors by stack trace fingerprint, grouping duplicate bugs into distinct buckets. Before any of this data touches an LLM, apply a regex pre-processing step to scrub all personally identifiable information from the logs. Sending a model a massive text dump of raw, duplicate logs guarantees hallucinations and high token costs. Strict filtering and deduplication ensure the AI receives exactly what it needs and nothing else. Now we pass the filtered clusters to the AI model selection block. You need a model with at least a 100,000 token context window, like Claude 3.5 Sonnet or GPT-4o, to handle dense stack traces. To prevent the model from guessing, your prompt must inject 3 specific variables: the full stack trace, the 5 to 10 log lines surrounding the exception, and the actual code snippet from your repository. Command the AI to output its diagnosis as rigid JSON. The prompt must mandate specific keys, including the root cause, a confidence score, and a needs human review flag. These last 2 fields are the variables that keep this entire workflow safe. Forcing structured JSON outputs turns an LLM into a reliable programmatic software component. With our JSON generated, we can build conditional logic. If the AI marks an error as high confidence and flags that no human review is needed, it triggers the automation path. This path calls the GitHub API, creating a new branch, applying the code fix, and opening a pull request with the AI summary. If the model returns low confidence, the workflow takes a fallback path, creating an informational Jira ticket instead of touching code. There is one absolute rule here: never give the agent permission to auto-merge. Every single AI-generated pull request requires a human engineer's approval before it hits production. The final block gathers all the PR links and tickets, formats them into a scannable message categorized by severity, and posts it directly to your engineering Slack channel. This routing logic ensures that when your engineers log in, they don't spend hours hunting through logs. They just review the proposed solutions. This nightly system performs the heavy lift error retrieval and analysis without requiring you to maintain a server or manage manual cron jobs. When you first deploy, disable the GitHub PR creation block. Run the workflow in report-only mode for the first 2 weeks. This probationary period lets you read the Slack summaries and evaluate the AI's accuracy. You use this time to safely calibrate the confidence thresholds before letting it touch your repository. Once you enable PR creation, track 2 metrics over the next 30 days: your mean time to detection, which should drop under 24 hours, and your PR merge rate, which tells you the quality of the AI's code. By automating the long tail of production errors, you identify and triage the bugs that used to sit in logs for days before anyone noticed. When you sit down on Monday morning, the investigative work is already finished.